Hello everyone. So in this video, let's review what is motion in two dimensions, and we'll do some example for projectile motion to understand how to solve problems in chapter the two-dimensional motion. So basically, to summarize, for motion in more than one direction, so the motion in x direction, so the variables, the position, velocity, and acceleration in x direction. Well, velocity in x direction only depends on position in x direction, and acceleration in x direction only depends on position in x direction and the velocity in x direction. So this is also true for y direction. So in one sentence, the motion in x direction, the motion in y direction, the motion in z direction, they are independent. You can treat the motion in these three dimensions independently by applying the kinematic equations we learned for one-dimensional motion separately in those three dimensions. So let's try to understand this independence of motion in different direction with this demonstration. So basically here you have a card. The card can launch a projectile directly up. Now if the card is doing constant velocity motion and at one point a trigger will trigger the ball project. Now if the ball was projected exactly pointing up, and it will goes back to exactly back to the card. Let's have a look at so this shows us the independence of motion in vertical direction, the motion in the horizontal direction, let's call it x direction, and in the vertical direction, let's call it the y direction. So in the x direction, when the ball was launched exactly pointing up, so both the card and the ball will be doing constant velocity motion in the x direction. So the movement in the x direction of the card and the ball is exactly the same in the x direction for same time interval. And in the y direction, of course, the card is not moving. The ball has a motion in y direction is a free fall motion. So basically, you can see the ball has the same motion in x direction as a card in x direction. So you can also see the motion of the ball in the x direction is just a kind of represented by the card, and in the y direction the ball is doing free fall. And this demonstration shows us the dependence of the motion in x and y direction. So now we're ready to discuss what is projectile motion. Projectile motion is an object that are moving in the air, and the only force acting on it is gravitational force. So the ball is the object, we call it the projectile, can have an acceleration. And the acceleration is always exactly pointing down and is negative 9.8 meter per second square. There's no acceleration in the x direction. Ax is always 0. And we call this kind of motion projectile motion. So we can apply the kinematic equation we learned. So in the x direction, because your ax is 0, so it's constant velocity motion. For constant velocity motion, we basically only have one kinematic equation, that x equals vx t, and your vx is always equal to the initial velocity in the x direction. So in the x direction, the projectile is going to do constant velocity motion. In the y direction, as we discussed, because it's influenced by gravity, there is acceleration in the y direction. Ay is negative 9.8 meter per second square. It's always pointing down, so we should use 5 kinematic equations we learned for constant acceleration motion in the y direction, right? So this is the third equation, and it's possible that we're going to use the other equations we learned for constant acceleration motion in the y direction. So let's use a few examples to help us understand how to solve problems in projectile motion. Let's first start with a pretty simple case. So you have a projectile project with initial velocity in the x direction. So there's no initial velocity in y direction. We know what is the initial velocity. This v0 is 9 meter per second. So let's build our coordinate system. This is x0, y0. So we just want to find out what's the position and the velocity of this projectile after 0.5 seconds. So let's first solve for the position. So what we know is, so we want to find out what is x, what is y for t equals 0.5 seconds. And in the x direction is doing constant velocity motion, right? Ax is 0. So constant velocity motion in x direction. So the displacement in x direction equals v0x times t. And your v0x should always equals to this v0 because your v0 is in the x direction. Your velocity is entirely horizontal. So your v0x equals v0, which is 9 meter per second. You have your time, which is 0.5 meter 0.5 second. The velocity is 9 meter per second, so your x coordinate is 4.5 meter. Now we need to find the y coordinate after 0.5 seconds. So we know what's the initial position, we know what's the initial velocity in y direction, right? The initial velocity is entirely in horizontal direction, so there's no y component for the initial velocity. The initial velocity in the y direction is 0. This is 0. And we have 1/2 ay t squared for constant acceleration motion. This is the third kinematic equation for constant acceleration motion. And we know ay is negative 9.8 meter per second square. Plugging in the numbers, 1/2 negative 9.8 t squared. T is 0.5 second. And putting in the number, we find displacement in y direction is 1.225 meter. So it asks you position, distance. Okay, we want to find the distance, which is the distance between these 2 points. And we already found out what is x, what is y, what is x, what is y. We want to find this d. So we just use trigonometry. This is hypotenuse, one side, another side. So it's x squared plus y squared. Again, with the numbers, we find it is 4.66 meter. Now we solve for the velocity in x direction and the y direction. So again, ax equals 0. So your velocity in x direction is a constant, doesn't change, 9 meter per second. Your vy is changing because your ay is negative 9.8 meter per second square, and your initial velocity in y direction is 0. Ayt because we want to find the final velocity. We know initial velocity, we know acceleration, we know t. We use the first kinematic equation to find out what's the final velocity. Plug in all the numbers. 0, 8.5, give me negative 4.9 meter per second. So I found out the velocity in the x direction and the velocity in the y direction. And if you want to find out what's the speed, then trigonometry again. It's 10.25 meter per second. Okay, so let's try another example. You have a swimmer diving off a cliff, and there is a ledge which is 1.75 meter wide. So it asks what's the minimum velocity the diver has to have that it jump into the water instead of get to the ledge. So in the x direction, it's doing constant acceleration motion. In the x direction, it's doing constant velocity motion. Because acceleration in x direction is 0. So the equation we use, change in x direction, displacement in x direction v0 xt, and it has to be greater than 1.75 meters. So when the swimmer gets to the bottom of the cliff, he has to get into the water rather than get to the ledge. So the minimum velocity has to be greater than 1.75 meter divided by t. T is the time that he flies in the air. Now, we're not going to find the information about this t in x direction, and the program has already given us all the information in the x direction. Now we need to find the t from the y direction. So find the time the swimmer flying in the air, find the t, the swimmer flying in the air in y direction. And what kind of information do we have in the y direction? We have theta y, displacement in y is 9 meter given. We have ay, we always know ay, which is 9.8 meter per second square. And we need another piece of information in y direction, so we need to know at least 3 variables in y direction to solve, right? We're looking for t. We have found 2 information, theta y 9 meter, ay negative 9.8 meter per square. What's other information we can have for the y direction? What's the initial velocity in y direction based on the program? So the diver running horizontally, so which means the initial velocity is entirely in x direction. So what's initial velocity in y direction? 0, right? Okay, so we have 3 known variables we need to solve for t. So which equation we're going to use to solve it? The third one, right? The third kinematic equation. So plug in all the numbers. And solve. We find that t should be 2 times 9 divided by 9.8. 1.355 seconds. So you can plug in this t here now. So you find there's a minimum velocity in the x direction, so the jumper get to the swimmer jump into the water. So its velocity has to be at least 1.3 meter per second. Okay, now let's try another example. This time the ball launched with initial velocity not pointing in the x direction, but it has an angle relative to the x direction. And for this one, we can always find out what is v0x, what is v0y. v0x is v0 cosine alpha 0. v0y is v0 sine alpha 0. And in the x direction is 22.2 meters per second. In the y direction is 29.6 meters per second. Okay, so in the y direction we have v0y. The question first asks us how long it takes for the ball to get from here to the highest point. So we know v0y, and then we know ay. So it's negative 9.8 meter per second square, ay, and highest point. So whenever we see highest point, which tells what's the velocity in y direction at the highest point. The velocity in y direction at the highest point is always 0 meter per second. So they give us 3 variables in y direction and ask us what is t. So we just need to find out which equation has these 4 variables: initial velocity, final velocity, acceleration, and t. And we find out the first equation just has it: 0y plus ay t1, and we plug in all the numbers. We'll find our t1 is roughly 3 seconds. So it takes 3 seconds for the ball to go from here to here. Now we actually know 3 variables from here to here. Now we have t, v0y, ay, vy. So you have a choice how to find this h, which is displacement in y, right? So let me just do it using the original 3 variables. So you have initial velocity, final velocity, acceleration, and we want to find the displacement. Now, which equation has these 4 variables? We have 2ay theta y equals vy squared. Subtract the v0y squared. And you plug in all the numbers. You can solve your displacement in y. So your h is 44.1 meter. Now we want to solve what's this distance the ball travel in the air in the horizontal direction. What is the total distance it travels? So in the x direction is always that x equal v0x times t2. We know this one, but we don't know t2, and we cannot find it from x direction, so we need to solve t2 in the y direction. So what do we know for t2? For flying from here to here in the y direction, we know displacement in y, which is 0 meter. We know acceleration in y is always negative 9.8 meter per second square. And we know initial velocity in y direction, right? Here. Initial velocity in y direction. And what is T2? So we need to find the equation that can help us solve T2. And I checked those 5 kinematic equations. I found the third one. Contains these 4 variables, and I can solve for my T2 from this equation now. Give me 6 seconds. So now the range, of course, is V0x times T2, plugging all the numbers. And the V0x is 22.2 meters per second from here. So we solved the example 3. Now let's try to do our next example. But we not only launch the projectile with angle relative to horizontal direction, but also the starting position and the final position is different. For the projectile, the height, which is vertical position, is different. So it asks us what is this L. So what do we know? We can find out what is V0y, and we know what is theta y. And we know, of course, AY, right? AY is, so apparently if you want to find this distance, you need to solve for t. What's the time it takes for the ball to fly from here to here? What is t? So you need to find your kinematic equation that has these 4 variables. So find the kinematic equation has these 4 variables, and it should be the third one. Plug in the number. So you have a quadratic equation to solve. So I just write it into a t squared plus b plus c form. So my a is negative 4.9, my b is 8.43, my c is negative 1. And I use a program that I put on BB, how to solve quadratic equation on your calculator. And I found there are actually 2 solutions. One is then which one I should choose, which t I should choose. So here you see delta y is 1 meter. So there are 2 possibilities your delta y is 1 meter. If your ball is here in this location, and this one will give us t equal 0.128 seconds. And here is t equal 1.59 seconds. So apparently I should choose this answer. This is a correct t. This one has to be discarded by observing the trajectory of the basketball. And so the horizontal range V0x times the t I just solved, 1.59, give me 11.24 meter. Now apparently this is a 3-point error.